Here is the problem. A bullet of mass 4 gram traveling in a horizontal direction with a velocity of 500 meters per second is fired into a wooden block of mass 1 kilogram, initially at rest on a level surface. The bullet passes through the block and emerges with its velocity reduced to 100 meters per second. The block slides a distance of 0.2 meters along the surface from its initial position. What was the coefficient of sliding friction between the block and surface? Let's draw some pictures. Here is a bullet. Here is the block. And the bullet is going through the block. The bullet goes through the block. And the block slides. What we know so far is the mass of the bullet. Let's call it M1. It's 0.004 kilogram. The mass of the bullet. The mass of the block. Let's call it M2. It's 1 kilogram. And we know the initial velocity of the bullet. Let's call it V1 initial. It's 500 meters per second. And the initial velocity of the block, which is 0, because the block was at rest. And we know the final velocity of the bullet is 100 meters per second. But we don't know the final velocity of the block at this point. We do know the block slides. Let's call this D. And D is 0.2 meters. Let's do some calculations. Let's use the energy equation. Initial kinetic energy plus the initial potential energy plus the work done by others is equals to final kinetic energy and final potential energy. For the block, it was at rest, so the initial kinetic energy was 0, and the block is not accelerating up and down, so the potential energy is 0. The work done by others is actually the work done by friction. It's equals to KEF. The work done by friction is 1/2 mv squared, which is 1/2 m2v2 final squared. But we don't know the final velocity of the block. What we can do is we can use the momentum to find the velocity of the block. We know that the momentum of the bullet is equals to the momentum of the block. So M1 changing V1 is equals to M2 changing V2. For the mass of the bullet is 0.004 kilogram. Change in velocity is 500 minus 800 meters per second. And the mass of the block is 1 kilogram. The change in velocity is V2 final minus 0. And we got V2 final is 1.6 meters per second. And let's plug that back in. The work done by friction is 1/2 mass of the block times 1.6 meters per second squared. And we got the work done by friction is 1.28 joules. In this problem, we're looking for mu. the coefficient of the friction. We know that the force of friction is mu times the force of normal. Since the block is not accelerating up and down, it's the same as the mu times the weight, mg. And how can we get the force of friction? We calculated the work done by friction, and the work done by friction is equals to the force of friction times the distance. The work done by friction is 1.28 joules. It's equals to force of friction times the distance is the distance the block slides, which is 0.02 meters. And we got the force of friction is 6.4 newtons. If we got this, we can get the mu. Let's plug that back in that equation. 6.4 newtons is equals to mu times mg, which is 6.4 newtons equals to mu times the mass of the block, 1 kilogram, and g, 9.8 newtons per kilogram. And we got mu is equals to 0.653. And here's the answer. Yay.